Stefan, how do we get an actual configuration onto an FPGA?
That is a fun multi-stage process. You know, when you start an FPGA, it usually has no configuration on it. Every time you shut it off, it loses its configuration. So usually it needs an external flash, an external storage. When the FPGA boots up, it sends some bits to the flash and gets back the configuration. Well, but how do we get the configuration into the flash? That is something that we can do, for example, with an FTDI chip. An FTDI chip is a bridge controller that translates a USB protocol, for example, into SPI. And when you attach this FTDI controller with the USB cable, it shows up as a virtual COM port device on your computer. You can then take a flasher like Open FPGA loader, for example, and use this program to take a bitstream and write that bitstream over the virtual COM port and the FTDI into the flash from where it can get loaded. But how do you get this bitstream? Well, the bitstream is a concatenation of bits. It's a linear block of information, and how this information needs to be ordered in this bitstream, that comes from a so-called seq-bit database. When you have a placed and routed design, then you can use a bitstream generator, to transform this design into a bitstream. But where do we get this placed and routed design from? Well, first of all, we need to know a little bit about the chip. So we need a so-called chip.db file. This encapsulates all the knowledge about the chip, where which transistors and logic gates are actually. And we need a technology mapped netlist. We need a implementation algorithm or place and route algorithm, PNR or implementation. So this algorithm looks at the TechMap netlist, which gates and which multiplexers and which whatever do I need, looks into the chip.db and says, oh, this is available on this chip at this specific point. And then it just places them into the design. But how do we get a TechMap netlist? Well, first we need a generic netlist. A generic netlist is a file that tells you in a very generic language which kind of logic operations need to be connected to one another. It doesn't know anything about the chip or anything. It just comes directly from your source code. And when we take that and run a TechMapper, the TechMapper will look into a cell library. A cell library is also specific to the actual FPGA that we're using, or to the FPGA's family. It tells the TechMapper which types of actual hardware is available on that chip. Then it looks into that, says, oh, I need an AND gate here, I need an OR gate there, take that from the library and put it into the technology mapped netlist. But how do we get this generic netlist? Well, sometimes when you're using Verilog, for example, you can write that directly, or you may write that directly. I myself, I'm using VHDL, so I will often need some additional steps in front of that, which is I might have a top.vhd file, which is basically a combination of a lot of other files or a lot of other modules. And those modules, they are in a library. So I have written my top.vhd file. I have a library of design units, and then I run the so-called synthesis or elaboration. And this elaboration step will take my top file and replace all of the references to library components with the actual library components and generate this generic netlist. Now, where do we get this library from? Sometimes you have library parts already pre-compiled because one of your coworkers built them, or you can also write your own design units. Then you need the VHDL rules and a program that's called Analyzer. And the Analyzer will build a library. Then you take the top.vhd file. With the top.vhd file and the library, you elaborate and synthesize. You build the generic netlist. You look at the cell library and take a tech mapper. You build a tech map netlist that is now specific to one FPGA family. From this tech map netlist, you take a chip DB, which is then more specific to the actual, not only to the FPGA family, but to the FPGA's architecture in a more specific sense. You take a pick, place, and route or implementation algorithm, you generate the place and routed design. Then you need a seqbit DB, which tells you at which point in the flash, which information has to be stored for the FPGA to understand your bitstream. You generate the bitstream, and then you take a flasher or loader program and a virtual COM port via an FTDI chip. You flash it into the flash, and the next time you start the FPGA up, it then reads its configuration from the flash.